Electronics for all. Good day for all. Most of the power supply these days are very reliable due to advancement in technology and better design preferences. But there is always a chance of failure due to a manufacturing defect, or it can be the main switching transistor or the MOSFET going bad. Also, there is a possibility that it may fail due to overvoltage at the input, though protection devices like metal oxide Varistor, MOVs, can be used as input protection. But once a MOV triggers, it renders the device useless. To solve this problem, we are going to build an overvoltage protection device with an operational amplifier, which can detect high voltages and can cut off the input power in a fraction of a second, protecting the device from a high voltage surge. Also, there will be a detailed test of the circuit to verify our design and working of the circuit. The following examination gives you an idea about the building and testing process for this circuit. If you are into SMPS design, you can check out our previous articles on SMPS PCB design tips and SMPS ME reduction techniques. How 220 volt mains overvoltage protection circuit works. To understand the basics of the overvoltage protection circuit, let's take the circuit apart in order to understand the basic working principle of every part of the circuit. The heart of this circuit is an operations amplifier, which is configured as a comparator. In the schematic, we have a basic LM358 operations amplifier, and in its pin 6, we have our reference voltage, which is generated from an LM78 12 voltage regulator IC, and on pin 5, we have our input voltage, which is coming from the main supply voltage. In this situation, if the input voltage surpasses the reference voltage, the output of the operations amplifier will go high, and with that high signal, we can drive a transistor which turns on a relay. But there lies a huge problem in this circuit. Due to noise in the input signal, the operations amplifier will oscillate many times before coming to a stable. The solution is to add hysteresis of Schmidt trigger action at the input, by configuring the operational amplifier with positive feedback. We can widen the margin at the input according to our needs. As you can see, we have provided feedback with the help of R18 and R19. By doing so, we have practically added two threshold voltages. One is the upper threshold voltage, another is the lower threshold voltage. If we look at the schematic, we have our mains input, which we rectify it with the help of a bridge rectifier. Then we put it through a voltage divider, which is made with R9, R11 56 kilo ohm, and R10 1.5 kilo ohm. Then we filter it through a 22 microfarad 63 volt capacitor. After doing the calculation for the voltage divider, we will get an output voltage of 3.17 volt. Now, we need to calculate the upper and lower threshold voltages. Let's say we want to cut power when the input voltage reaches 270 volt. Now if we do the voltage divider calculation again, we will get an output voltage of 3.56 volt, which is our upper threshold. Our lower threshold stays at 3.17 volt as we have grounded the operational amplifier. Please note that our practical values will differ a bit from our calculated values due to resistor tolerances. Now that our design is ready, it is the time etch and solder the board. After the etching, drilling, and soldering process are finished, testing over voltage and current protection circuit as shown. This circuit is a very useful auto cut-off circuit to the safety of any electric or electronics equipment from high voltage. This is very simple and easy circuit. This circuit automatically cuts the current supply to any appliance from the input circuit. And when the voltage decreased at a normal level, then automatic on the supply. Hope you enjoyed the article and learned something useful. If you enjoyed this video, please like it, subscribe, and click the bell icon to get new video updates.